welcome back to you all to Data Crack. So I'm back with a new topic. The topic for today is probability distribution function. Before moving to our probability distribution function, first of all we must understand what is random variable in statistic or probability, what is the possible outcome. Once we will understand about all this concept, we will move toward the probability distribution function. What is the difference between probability distribution and probability distribution function? So let's start with the random variable. So what is random variable exactly in probability? Or normally random variable is a set of a possible outcome value from the random experiment. All right. For example, when we toss a coin, for example, when I toss one coin, in coin there is one head and another is tail. All right. So our possible outcome will be here head, either tail, right? So our possible outcome will be head or tail, which is denoted by x. All right, but here it is denoted by small x. But in case of algebra it is denoted by capital X. All right. As here we have already said that linear algebra variable and random variable is that random variable that hold multiple value. Means in normally in case of a probability, our random variable hold multiple value. For example, in case of a head and tail, all right, in case of a coin toss, in case of a coin toss, my x variable will hold the two possible outcome, that is head or tail. Or we can say that head is 1 or tail is 0. All right, means we will have multiple outcome, but in case of a algebra we have only one single outcome or value which is unknown. But in case of a algebra it is denoted by capital X, but in case of a probability it is always denoted by small x. All right, now before understanding about the random variable, we just need to understand about continuous random variables and discrete random variable. Well, it is normally generated from data type. All right, we normally have a two type of a data. One is continuous and another is discrete. Discrete means countable data. Whereas we're talking about the continuous one, it is the data that cannot be counted, or it is on float value. All right, for example 3.7, 5.3. But in case of when we have a fixed value like 4, 5, 6, we can easily count it, right? So this type of a data is normally the discrete type of a data, and this type of a data is normally the continuous type of a data. Even the probability is means you can normally say that continuous random variable deal with normally continuous data, whereas discrete deal with discrete data, means countable data. All right. So once you have understand about the data type, means we normally have two type of data type, that is continuous and discrete. Even the random variable that is generated, one is continuous and another is discrete. All right. Now well, speaking about the probability distribution, what is this probability distribution exactly? Well, the probability distribution, just imagine I have just said that I just want the probability of getting I have just done one experiment where I am normally throwing my dice, okay, for 5 times or 6 times. In such a situation, we can normally create a table and we can find for each means probability of getting 1, probability of getting 2, 3, 4, 5, 6. For each time we can draw a table and we can for each we can find the probability. Alright, means through table we are just going to find the probability of that particular uh, number or the chance of getting that number. Okay, it normally, well, speaking about probability distribution, it normally plot here probability and here normally the random outcome. Okay, possibility of our random outcome. But imagine when we have a high sample space. Alright, in some scenario we have to work with the high sample space. Means you can just simply say that I have performed an experiment where I have tossed coin for 1 lakh time. Okay, 1 lakh time. In such a situation, 1 lakh time. In such a situation, is it possible to make a table? Alright, is it possible to make a table and calculate probability for each of them one by one? It is really so much difficult, right? So, this type of a problem is normally solved by our probability distribution function. Alright. So, normally we can say that in probability distribution, we normally create a table. Alright. To find the probability. Of our possible outcome. But in case of a probability distribution function, when we are working with a large sample space, we normally use a probability distribution function to find the probability. Alright. Now, well, speaking about probability distribution function, probability distribution function is nothing but it is simply a mathematical function that describes the probability of obtaining different value of a random variable in a particular distribution. Alright, even while speaking about probability distribution function, we normally have two type of a probability distribution. The first one is discrete and the second one is continuous. Normally discrete probability distribution when we have a discrete type of a data, this is a type of a data. Alright, and when we have a continuous type of a data, we normally use probability density function, and when we have a discrete type, means countable data, we normally use probability mass function. So what it is, when we just need to keep in mind, when we have countable type data or discrete, we normally use probability mass function. On the other hand, when we have continuous type data, we normally use probability density function. Alright, I think you have understand till here. Now let's move to what is this probability mass function and probability density function in detail. Alright, well, speaking about probability mass functions give the probability that a discrete random variable is exactly equal to some value. Alright, means normally when we have normally a discrete type of a data, alright, which is countable, in such a situation we use a function to find probability. Okay, it is known as probability mass function. Normally probability mass function shows normally probability mass function shows the probability and the possible event. Okay, and you can simply use the formula to get your probability. Alright, now while speaking about probability density function, um, by name only. Even as previously I have said, when we have said density function, when we have a continuous type of a data, at that situation we normally use a function which is known as probability density function. All right, here we normally, in case of probability density function, we normally plot probability density in y-axis and in x-axis normally random outcome. Okay, we don't plot here probability, but in mass we normally plot a probability. All right, now we'll speaking about cumulative distribution function. For example, we want to in a question we sometimes we want to find the probability. For example, I am provided with 1 to 100 data, okay, and I just need to get the probability in range between 1 to 10. In such a situation, in order to get a range of a probability, we normally use cumulative probability distribution function. All right, normally while speaking about the discrete, uh, it normally add up the probability from beginning. For example, if I want till 15, then it will add from 0 1 till 15. All right, for continuous, it normally integrate add up the area under curve, means from minus infinity to that value of x. All right, now speaking about probability, speaking about cumulative probability distribution, it is always increasing because we are going to find the range till that particular data point, right? So it is never decreasing. It normally ranges from 0 to 1. All right, now even in figure you can see that while speaking about the probability mass function, which normally deal with discrete type of a data. The reason we have plotted in y-axis probability and in x-axis possible outcome. Similarly, while speaking about the continuous type of a data, which is not countable, here we have just uh, plotted probability density function and possible outcome in x-axis. All right, now most of the time in interview it is asked that in probability mass function, that is our this probability mass function may in y-axis normally represent probability, but not in probability density function. It represent probability density. Why? What might be the reason? So in probability mass function, which is used for discrete value means we normally can count it, right? Each value has finite exact probability, means for example, if I want to get the probability of a 2, I can just normally get the exact value. But while speaking about 2.5, can I get the exact probability? Not, right? And in y-axis we normally show the actual probability, but in probability density function which is continuous variable, which cannot be normally count, where the probability of any single exact value is 0 normally. So instead of probability over a range, we use area under the curve. All right, we don't use the probability, rather than that we normally use area under the curve. So in y-axis we normally use the probability density function, not probability itself. This difference is just because continuous data has infinity many possible outcome. It is not fixed, right? But in discrete it is normally fixed, right? But in continuous it is not fixed, it is normally infinitive. The reason we normally use probability density rather than the probability in our probability density function. All right, now moving ahead to the type of a probability distribution, we normally have two type of a probability distribution. The first one is discrete, which is countable, as I have already described previously too. means discrete means which we can count, and continuous means which we cannot, and even our probability is not exact, right? uh, in discrete probability we do have Bernoulli distribution, binomial distribution, uniform distribution, and Poisson distribution. And similarly, in continuous distribution, we normally have normal distribution, chi-square distribution, exponential distribution, logistic distribution, and student T distribution. So let's understand what is this discrete distribution. We normally use discrete distribution when our random variables take finite or countable variable, means it is normally discrete, right? Finite or countable means it is normally discrete. We normally use binary distribution when we have two possible outcome such as yes or no, such as failure or success. When we have a two output, normally in classification also we normally have two class 1, right? So in such a situation we normally use a Bernoulli distribution. For example, twisting a coin, there is a possibility of a two output, whether it can be head or tail. All right, but now let's talk about binomial distribution. When we perform our Bernoulli trial for n or independent time, and the count number of a success in an trial. For example, we normally twist coin for 10 time. All right. Well, speaking about the parameter, here we have n and p. Now moving to the next type of a distribution, that is uniform distribution. It is also a type of a discrete distribution where all outcome are equally likely. For example, rolling of fair coin. Okay, fair coin. What is the probability of getting 1? It is 1 by 6, right? What is the probability of getting 2? 1 by 6. What is the probability of getting 3? 1 by 6. Similarly for 4, 5 and 6. It's 1 by 6, 1 by 6 and 1 by 6. Means each of them have equal chance, right? So it will normally meet a rectangular type of a distribution. All right. Similarly, now moving to the next type of a distribution that we have here is the Poisson distribution. Means here normally model the number in the fixed time of an interval. For example, we want the number of a email received per hour, number of a tasks complete in 5 hours. Okay, whenever we are provided with the time interval, we normally use a Poisson distribution. All right. Now let's move to the continuous distribution. Well, continuous distribution, when we are provided with the continuous data where we cannot calculate fixed probability, right? Probability outcome. Now, well, speaking about the continuous distribution, it is a really important topic even in terms of statistics, because normal distribution is normally a bell-shaped curve, symmetric about the mean. Most common real world data, for example height, weight, normally the well, speaking about the parameter, here we have mu and the standard deviation. In normal distribution normally the mean is equal to median is equal to mode, means all the value, means most of the data is surrounded around the central, and less as you move far away. Even there is one empirical rule that in the first standard deviation, in the first standard deviation there is 68% of a data. As you move to the second standard deviation, it covers 95% of a data, and as you move to the third standard deviation, it covers 99.7% of our data. And even normal distribution help us to identify outlier. For example, if the any data is outside this, we consider it as outlier. All right, normal distribution is really important uh, in statistic for solving various type of a problem. All right, now moving toward the next type of a distribution, that is chi-square distribution. That we normally chi-square distribution that we normally use during hypothesis testing. Okay, when we are provided, for example, when we are provided with the categorical column and we want to check the relationship between them, at that situation we normally use the chi-square distribution. All right, now we have even other type of a distribution like exponential distribution, which we normally model time between event in a Poisson process. All right, time until the next customer arrive. Here the parameter here we have is lambda. Similarly, we have here distribution similar to normal distribution, but have heavier tail. Normally tail is heavier. All right, common in logistic regression, such as sigmoid function. All right, we do have the sigmoid function, right? Similar to student t distribution, it is also like a normal distribution but used when sample size is small. Normally say that less than 30 is equal to or less than 30. All right, at that time we normally use it. It normally have the heavier tail to account for uncertainty in population standard deviation, and it also define the degree of freedom parameter. I hope you all understand about the probability type of a probability. What is the difference between probability distribution and probability distributions function? Yeah, that's it for today. Thank you so much.